Good afternoon, ladies and gentlemen, and thank you very much for being here with us on the first day of our AUC Research and Creativity Convention 2018. It's definitely an honor and a pleasure, and I can't even find the right words to be honored by having with us Professor Magdi Yacoub. I've known Professor Yacoub for over 10 years or so, and I always believe that he is a gentleman who is surrounded by love, not only for his spirit and for his perseverance in research and for his caring for people and so on, but for being so humble and for being so understanding of others and so on. So I guess I will just leave to Provost Ihab Abdurrahman to properly introduce Dr. Magdi Yacoub, and then we will listen to his talk today. Thank you very much for joining us today.
So, dear students, colleagues, Dr. Abada, Dr. Ashraf, Dr. Magdi, Dr. Ala, good afternoon. I'm pleased to welcome you here today, whether in person or via our social media live streams. Today is a milestone in our research history. What started out as a research day grew to research week before morphing into what brings us here today, the Research and Creativity Convention. The redesigned Research and Creativity Convention celebrates the intellectual output of our diverse disciplines. The RCC provides an arena to showcase the arts and humanities alongside science and engineering, social sciences and business. I'm proud of the development that have been made of this event. I believe that events like the RCC that offer an outlet for students, especially undergraduate students, to showcase their abilities only improves the quality of education that we offer. This impact on the quality of education is reiterated in the creation of the award for the disciplines, a competitive prize at departmental level which puts multidisciplinarity, collaboration, and student engagement at the heart of the prize. The distribution of the award will be at the closing ceremony, which will also feature a panel on celebrating failure. The panel will feature 3 of AUC faculty members, Dr. Amr Sharawi, ex-provost and the chair of the Senate, Dr. Ala Idris, the associate provost for research, innovation, and creativity, and Dr. Huda Mustafa, the director of the Center of Learning and Teaching. Today, as we kick off the convention, we're honored to have with us one of Egypt's favorite sons, Sir Magdi Yacoub. Sir Magdi is a world-renowned cardiac surgeon and researcher. He's also the founder and the director of Magdi Yacoub Research Network. Sir Magdi has established the largest heart and lung transplantation program in the world, with more than 2,500 transplant operations performed. And he has developed novel operations for a number of complex congenital heart anomalies. Sir Magdi has an active interest in global healthcare. Delivery with particular focus on developing programs in Egypt, the Gulf, Mozambique, Ethiopia, and Jamaica. He's also the founder and the president of the Chain of Hope charity, treating children with correctable cardiac conditions from war-torn and developing countries, and establishing training and research programs in local cardiac units. Here to deliver the keynote address titled Creativity, an Elusive Target, is Sir Magdi Yacoub.
Thank you very much for your kind words. It is indeed an honor and a privilege to be here to address this very distinguished gathering.
ما كناش بنصور اصلا.
Sorry? particularly the students who represent the core of the American University, AUC in Cairo, which has been and continues to be a beacon in the region and beyond. This is wonderful, but that depends on this multidisciplinary approach to teaching. And importantly, the theme of this symposium, creativity and innovation. And that's what I have been asked to talk about. Now, this is quite a difficult topic, if you like, but at the same time, everybody understands somehow what is creativity, what is innovation, and as I put it in my title, can it be a target? Or just does it happen? And if it is a target, how can you target that? Maybe we can go together a little more. So I will start by talking about definitions. And then I will move on to give examples from my own limited experience in the subject of creativity. And I will talk about why it is absolutely glorious, but it also has threats. And there are lessons from the Titans, and that is from the Greek mythology, which have taught us a whole lot of things about creativity, philosophy, and how to think in the future. I will talk about something which I have a lot of experience with, as you have heard, and that is transplantation, and how that has given way to another branch of medicine and science, which is called regeneration, but just as a model. And I'll talk about the global involvement. I'll talk about the future. Now, what is creativity? And we have heard repeatedly that science is defined as the search for the truth. And that has been articulated by many people, particularly modern philosophers of science, that science is the truth, is the search for the truth, but at the same time, the truth is unachievable. More about that. Now, one of my greatest heroes and role models is the late Sir Peter Medawar, who won the Nobel Prize for his work, creative work, on transplantation, tissue transplantation. And for a long time, conventional wisdom had it that individuals are almost holy and independent, and that you cannot transplant tissues from one person to another. Why? This individualistic thing. Because it was said that the immune system, which everybody has, all animals, both vertebrates and invertebrates have, is invincible. It will just stop anything. And it was only Sir Peter who showed that this is not true. Challenging dogma. more about that. He went on to publish a single paper, not very long, in 1952, entitled Induction of Specific Immune Tolerance. Challenged dogma, induction of tolerance. That means you can transplant from one individual to the other, from one animal to the other. He showed that you can take skin, heart, liver from one rat to the other, and tolerated that without drugs. And that's what he called specific immune tolerance. And it's a great story because actually the paper which changed history and was very creative, of course, was by Billingham, Brent, and Meadowa. Now, Billingham was apparently a research fellow in Oxford, working for the great man, the professor, Sir Peter Meadowa. And they were experimenting with injection of bone marrow from one rat to the other. And one afternoon, Sir Peter walked into the lab and said, Rupert Billingham, you are giving the lecture to the Oxford Research Society, people like you, but this is a very high-powered society. Next week, he said, sir, what am I going to talk about? He said, hey, Rupert, your experiments. He said, what is it with my experiments, sir? He said, induction of specific immune tolerance, Rupert. He said, sir, I cannot see it. No. As a matter of fact, I'm going to France. I've booked a holiday, and I'm not going to be here, sir. And so he said, Rupert, but I promised. He said, I'll give you all the data, sir, and you give the lecture. So Meadowa went and gave the lecture about induction of immune tolerance. Actually, Billingham was in the back, hiding, listening to this, and everybody said, incredible, wow, the immune system has been conquered. So on Monday, Rupert allegedly came back from France. He never went, and said, sir, I hear it was a great success. He said, yeah, when are you writing up for Nature? He said, me writing it for Nature? You gave the lecture, you write it, sir. She said, no, it's your work. I'm going to help you write that paper, which changed history. That's another lesson, which is humility. And he insisted. They wrote the paper for him. And it is Billingham, first author, Brent, who's another immunologist, very distinguished, and Meadowa, who won the Nobel Prize. Meadowa, of course. But Sir Peter, who I had the privilege of meeting, how long have I got? But I'll try and time myself. Sir Peter, I had the honor and the privilege of meeting and talking to when I was a very young junior registrar in London. And I was struck by his humility, his intellect, and just everything. And he defined creativity as, he called it an art as well. Creativity is the art of producing ostensibly out of nothing something of beauty, order, or significance. Please note the words, The first is beauty. Beauty is in the eyes of the beholder, something beautiful. Order, discipline, and significance, obviously, to mankind. So the man was an absolute genius. But it brings us to this definition of creativity. Just what is creativity? It means different things to different people, and there was a program on the BBC on questioning several Nobel laureates to define creativity. And the answer, all of them, was, I don't know. I honestly don't know. It just happened. And they then went on to say, and I believe that's absolutely true, that if you want to be creative, you really need to do two things. One is be focused. Really go for one topic and try very hard to understand everything which has been written about it, and then go beyond it. Then the question was, can you predict when you will do the next step, which is the creative, innovative? And the answer was no. I actually surprised myself one morning, having had a big breakfast, and I was just rambling around, and suddenly this thing came. Everybody was surprised, not least me. It just came. So that is a bit of an exaggeration, because you must have this subconscious mind which goes on digesting what you're thinking about even when you're sleeping, and that has been validated many times. And that is a net result of the focusing. So I cannot stress the word focus, focus, focus. And then when you are preoccupied by something, your inner mind, whatever that is, different parts of the brain do different things, carries on trying to solve the problem, even when you think you're not thinking about it. You're still thinking about it. The second point, which they all agreed, and I cannot agree more with them, I'm not a Nobel laureate, was the teamwork. And I cannot stress that point further, because you cannot clap with one hand. You really need two hands. You need a lot more. You need people. You need minds. You need everybody. And there are many, many stories to prove that point. The latest, which I think is very gripping, was a study in Nature not very long ago, showing millions of fish going around the ocean. And the bigger the number, the better the decisions to avoid danger. So don't be frightened of working within a team. In our own specialty, we really have to rely on everybody. And when we go on the round, we have the cardiologist, the heart surgeon, the anesthesiologist, social worker, the nurses, the technicians, and the scientists from the lab, all going to see what the problems are. And having other minds on the job is part of the story of creativity. This is one of my favorite pictures, and who knows this goddess. This is Maat, the goddess of the truth. And Maat, as you can see, and as Karl Popper and others have said, goddess of the truth is beautiful. She is extremely beautiful. But equally, they talk about it, the truth is, absolute truth is unattainable. If you come near Maat, she grows these huge wings and flies away. Does that make you despair and stop? I don't think so. It is the other way around, because you say, well, I'm near the truth, and this is current knowledge. I will strive more to get nearer. And this goes further to another point, which is humility. Because Karl Popper, again, the philosopher of science in the 20th century, said that science progresses by theories, which he called conjectures. And he says it's a big mistake to try and prove your theories. You should try and refute them. And he wrote a whole book called Conjectures and Refutations. I recommend that to you. He said, this is very unfortunate, but the lucky thing is that our peers come to the rescue and supply the refutations. So when you send a paper to Nature and you get 6 papers of reviewers knocking you down, don't be cross. They're pushing you towards the truth. If they succeed in refuting, then they are nearer the truth. If they fail, you are nearer the truth. So refutations are very, very important. And accepting other people's criticism is absolutely essential. In humility, and if somebody says, I know it all, you can be sure that he knows nothing. So this is another point. And now I get a bit technical, and I hope many of you would understand all this. But these are just but examples. There is a molecule called PCSK9. What is PCSK9? I've written with one of my colleagues from Aswan an editorial in one of the journals entitled The Discovery of PCSK9 Inhibitors, A Tale of Creativity and Translational Research. Why did we call it that? Because this is an Egyptian chap called Nabil Saida. Nabil is a graduate of Asr al-Aini. I'm proud to say, because we are both graduates from Asr al-Aini and we cherish the teaching we had there. But Nabil went to Montreal and wrote this incredibly original paper in Nature Drug Discovery about a molecule which belongs to what he called pro-protein convertases. And that is the father of PCSK9. What did this do? Now, that molecule which is shown in blue and color is PCSK9, the convertase Nabil Saida described. And it was found by chance almost, but he actually predicted it and told it, a group in Paris that they were despairing because you sometimes inherit deficiency in what we call the LDL receptor. The two chaps here, Goldstein and Brown, won the Nobel Prize for discovering the low-density lipoprotein receptor some time ago. And that is what was shown to produce heart attacks and dreadful. And Nabil suggested that there is another inherited condition which is due to overactive PCSK9, that molecule he discovered, almost by chance. Everybody, not only me, is convinced that Nabil Sider, this chap here, is going to win the Nobel Prize. Well, I mean, many people are campaigning for that, and I'll be surprised if he doesn't. Why? Because he showed then that two things. There is serendipity, obviously, but the brain of the guy, he's working in Montreal. I went to visit him. Very humble. He took me to lunch. He was here. He grew up in Egypt. It shows that you guys can do everything. You're incredible. And then, because he showed the two things were that in Paris, this family of people dying of heart disease because of lipids everywhere, with a perfect LDL receptor from Goldstein and Brown not working. Nabil said, look for PCSK9 overactivity. And it was. And a new molecule has been discovered. In Dallas, Texas, the opposite was discovered. They found a 70-year-old, somebody almost as old as I am, but a bit younger, a lady who was a cheerleader with perfect arteries, an Afro-American. And then they found that she had defective PCSK9 gene. So the two things together made people, particularly pharmaceutical companies, go mad and develop a drug. There are several drugs, either antibody, different inhibitors. And guess what? If you give PCSK9 to people, even if they are on statins, like I am on statin, and they have a very high LDL levels or cholesterol, whoops, it goes right down. So people say, oh, is that going to have a clinical significance? Is it going? Sure enough, within 2 years, within actually less, the incidence of heart attacks went down dramatically. Is that creative? Of course. And there are examples like that. Just hard work, working. When I went to visit Nabil in Montreal, the Canadian government has given him a whole institute, and he's directing it, full of young people like you, researching into different aspects of that molecule, which will save thousands, if not millions, of people. But importantly, it is all to do with discovering basic mechanisms, working together. The whole institute is working on the one molecule. I've already mentioned to you intellectual humility and why is that important. And I talked to you about the glory of discovery, healing, teaching, human interaction, but there are threats, doing harm, false discoveries, over-recognition. When people say, oh, you're a star, there are no stars. Destructive competition, losing contact with each other. All these are threats. dreadful. There are many lessons from other areas, and I like this one in particular, which is to do, who knows Prometheus? Yeah, several people. Prometheus looked down to earth and saw men crouched in caves, half naked, cold and shivering, and asked his father, Uranus, why has he kept human race in ignorance and darkness? Uranus said, what you call ignorance, my son, is innocence, my friend, as long as no one convinces them that they are not happy, they are happy. Prometheus, of course, in a defiant manner, didn't believe that, went to the sun, lit up a branch, came down to the earth, and brought warmth, which I think the people shivering had heart failure, and light, which is knowledge like you are having. But he has to pay the price of having a vulture feed on his liver every night. But because even then there was stem cell biology, he grew up a new liver and lived happily ever after. So Prometheus is a very good example of creativity. There are many examples from the Greek mythology. For example, I like a lot of this mythology. It never happened, but the ideas which elevate thinking. And for example, Apollo, who was the god of intellect, the arts and healing, implies harmony, balance, rationality, loyalty, and discipline. These are all qualities which are badly required if we are to perform in research or service of mankind. So I can go on giving you some examples of transplantation, for example. And transplantation has been a qualified success. Yes, it has been a great success, because only 60 years ago it was thought to be a fallacy for the future. And now it's a model for success. But it is not absolute success. It's a qualified success, and it needs a lot more. Why is it a qualified success? I have patients who were brought in the middle of the night dying, and I see them 34 years later. Wow! What is better than life or happiness? But it's not all the patients. It's only 20%. So what happened to the 80%? And as we always say, with maturity comes accountability. And therefore, we have to do better than that. And this is the man I've been talking to you about, Sir Peter Medawar. His mother was Lebanese. His father was Lebanese, Medawar. And his father was English. And he was born in Rio de Janeiro. And he was educated in Oxford. And as he put it in his autobiography, you cannot get more mixed up than that. But he has done a whole lot of things. And this is, transplantation went on to regeneration. And there are definitions for that. There are many molecules which change during recovery of the heart. And you don't know which one is important. And it is like this little boy trying to deal with a swarm of insects attacking a crop with a broom. There's no way he's going to make an impression on that. However, there is a whole new science which is system biology, and I've written about that because in system biology, you look at what you call decision nodes and collecting nodes and try and sort out what's happening. So that's very exciting, but it is for young minds like yours, system biology, artificial intelligence. A lot to discover, huh? Well, that it needs creativity. Now, cell therapy, stem cells. I mentioned that Prometheus benefited from that some time ago. However, there has been massive hype about cell therapy. It was discovered in the lab, but it crossed to the clinic very, very quickly, prematurely, we think, and crossed that bridge over what has been dubbed the Valley of Death, because many people fell in that valley and died. The clinical trials have been given very fancy names like Caduceus, Scipio. The picture you see there is of Scipio, who is a Roman leader who was never defeated, as if the cells were going to do what Scipio did. Unfortunately, it didn't. And therefore, we have to be very critical and not overestimate discoveries. And hype can be very dangerous to the community and to scientists. So humility is essential. Tissue engineering is very promising because it's moving slowly, and now we're realizing that in between the cells there is a scaffold, extracellular matrix, which instructs cells, and we're trying to decipher that in terms of the so-called intelligent matrices. And this is a colleague from the Zuwail city where we're working together on intelligent matrices. And then differentiating cells from skin, either directly or indirectly. And this is a surgeon called Christopher Rao who worked in the lab and showed that the cells can be programmed to be heart cells. And the so-called indirect reprogramming. This chap, Shinya Yamanaka, is an absolute genius. He's obviously, as you can tell from the name, Japanese. And Yamanaka won the Nobel Prize like 6 years after the first paper of inducing indirect reprogramming of skin cells into undifferentiated cells, what's called IPS, induced pluripotent cells. And then you can differentiate them into anything, into heart muscle, into cartilage, into brain cells. And people didn't believe him, but he was right. Using just 4 transcription factors, OSKM, and this is very, very promising indeed. You have a skin cell and produce an undifferentiated cell and then differentiate it again. It went further, and this is Deepak, who's a pediatric surgeon, actually pediatric cardiologist, who went on to show that you don't need to actually de-differentiate the cells, you can directly program them into heart cells. Almost science fiction, huh? But he did it with a whole lot of molecules listed on this slide, like 12. So it was more difficult. Now, another person, Eric Olson, from Dallas, Texas, did the same in humans with even more molecules. This is Hisham Sadeh, who is a graduate of Ain Shams, I think, He's working in Dallas, Texas, and we're working with him on a new strategy of inducing heart cells to divide, which is extremely exciting indeed. And that's another therapy, way of getting the heart to recover. Gene therapy is important, but the future, as we all say, the future is here, is in this new technique of gene editing. There are several strategies for gene editing, either by RNA, by TALEN, but the latest is CRISPR-Cas9, which you can produce a transgenic animal in a few weeks, not years or months. It is said that you can buy a CRISPR-Cas9 kit on the internet and start playing at home with your own cells. Why is that exciting? It's exciting but also dangerous, because it is relatively simple but very, very clever. And it was learned from viruses, my God, from bacteria, which get attacked by viruses. And they protect themselves by taking a small sequence of the virus and keep it, link it to an enzyme, and next time the virus comes, it cuts its DNA. And that's the CRISPR-Cas9. So you can have any sequence of any mutant gene and cut it wherever you want. But we know that human genes, when you cut them, they heal. So you can get rid of the defective gene, or you can insert whichever gene you want. So it's almost frightening, because it goes into the germ cells and can be inherited. So the ethics of that is questionable. It is society who should be in charge. But for the first time, we have a means of curing inherited heart muscle inherited disease. And here in Egypt, my God, we have a lot of inherited disease. We have more than 1,000 inherited heart muscle disease in Aswan, and we need to cure them. We do it by surgery and indirect means, but we need to sequence the genes, and we have a study of the 1,000 Egyptian human genome study called HVOR, because we need to compare what's normal and what's abnormal. Before we were comparing it to American genes, the 200,000 genome, but we were not represented in that, which was a disaster. So this is the journey of creativity. I end up my talk by global involvement, because we need to be creative in this, because the massive problem exists where 80% of the population of the world have no access to recently acquired knowledge and benefit. And who cares, who acts, who pays, are things which needs to be addressed. And we've been working on that very hard in the last few years, as you have heard. And the Aswan Heart Center is an expression of that, because there is really a neglected community which needs to have the latest in science and technology to treat their hearts, and we just see it in a big, big way. But also to create a new generation of Egyptians who are straddling medicine and science is very, very important. And that's what's happening. And the new Aswan, the current Aswan, is functioning when we do over 1,000 open hearts and 3,000 interventions with catheter and 20,000 outpatients, and it's oversaturated. So the new Aswan is being built now. We'll start, and that was designed by Lord Norman Foster in the UK. And it's a whole campus of science and medicine to carry on with this. It looks like Sydney Opera House, but obviously at the top are a reflection of the Felucca, and that is to conserve energy and use only solar energy. And that is the aerial view of how it's going to look like. And the journey has started. And this is, every room for the patient will see the Nile, and that will hasten their recovery. And it's all for free. It's humanitarian. And now we have 650 staff. They're growing. So science and medicine offers unprecedented opportunities for discovery and, most importantly, alleviating human suffering. And that there are threats, and I enumerated some of them, not all of them. And creativity and innovation, the subject of this meeting, is essential for achieving any target in research. Thank you.